A Soviet engineer stares at a gutted tractor engine in a Kharkov factory, knowing he has months, not years, to build the impossible. Germany's Panzers run on gasoline that burns like torches when hit. What if the answer to defeating them was sitting in Ukraine's wheat fields all along? September 1937. Kharkov, Ukrainian Soviet Socialist Republic. The morning shift bell rings across the Kharkov locomotive factory, but Mikhail Koshkin doesn't hear it. The 42-year-old chief designer stands in workshop number 522, a special design bureau hidden behind unmarked doors in the factory's eastern wing. Before him, technical drawings cover every available surface, a revolutionary tank design that exists only on paper. The Soviet High Command has given him an impossible task: create a medium tank that can outrun, outgun, and outlast anything Nazi Germany can field. But there's a problem that keeps Koshkin awake at night. The tank needs a heart, an engine powerful enough to move 30 tons of sloped armor at speeds conventional wisdom says are impossible. Koshkin runs his oil-stained fingers across the specifications one more time. The design calls for a 500-horsepower diesel engine. Nothing like it exists in the Soviet Union. The Germans use gasoline engines in their Panzers, reliable, proven, but vulnerable. A single tracer round can turn a German tank into a crematorium for its crew. Diesel burns differently, slower, harder to ignite. But diesel engines are heavy, underpowered, designed for trucks and tractors, not for the kind of performance Koshkin's revolutionary tank demands. Outside the workshop windows, snow begins to fall on Kharkov's industrial district. The calendar shows 2 years until 1939, when Stalin expects to see a working prototype. 2 years to solve a problem that German, British, and American engineers have declared unsolvable. Koshkin lights a cigarette, exhales slowly, and makes a decision that will change armored warfare forever. He walks 3 blocks through the factory complex to Building 75, the Kharkov tractor plant. The smell hits him first: diesel fuel, metal shavings, the sharp tang of welding work. Rows of half-assembled tractors line the production floor, destined for collective farms across Ukraine. Koshkin stops in front of a BD-2 tractor, its engine exposed during assembly. The BD-2 diesel is a beast, a V12 aluminum block engine designed by engineer Konstantin Chelpin to pull plows through Ukrainian black soil. It produces 131 horsepower, runs for thousands of hours between maintenance, and most importantly, it's already in mass production. Koshkin circles the tractor slowly, his engineer's mind calculating. The BD-2 is too weak for a tank, too slow, too simple. But the basic architecture is sound. What if it could be transformed? Not replaced, transformed. He pulls out a small notebook and begins sketching modifications. Bore out the cylinders for more displacement. Add forced induction. Redesign the fuel injection system. Increase compression ratios. What if a tractor engine, purpose-built for reliability in the harshest conditions, could be evolved into something no one expects? January 1938. Kharkov Diesel Engine Design Bureau. Engineer Alexander Morozov watches Koshkin present the concept to a room of skeptical colleagues. On the blackboard, Koshkin has drawn a comparative analysis. German Maybach HL120 gasoline engine, 300 horsepower, 12 liters per 100 kilometers on good fuel volatile. The proposed Soviet V2 diesel, 500 horsepower, 6 liters per 100 kilometers, fire resistant. The numbers seem impossible. You want to make a tractor engine produce 500 horsepower? Senior designer Nikolai Kuksinski doesn't hide his skepticism. The BD-2 barely makes 130. You're talking about nearly 4 times the output. The block will crack. The pistons will seize. The crankshaft will snap. Koshkin doesn't argue. Instead, he unveils a section model of his proposed V2 engine. The resemblance to the BD-2 is obvious. Same V12 configuration, same basic dimensions. But everything has been intensified. The cylinders are bored from 120 millimeters to 150 millimeters. The stroke is lengthened to 180 millimeters, bringing total displacement to 38.8 liters. massive compared to the 35 liters of German tank engines. The cylinder heads are redesigned with 4 valves per cylinder instead of 2, allowing the engine to breathe at higher RPMs. A centrifugal supercharger, borrowed from Soviet aircraft engine research, forces extra air into the combustion chambers. The BD-2 was designed for reliability, Koshkin explains, pointing to specific components. Tractors run 18 hours a day in dust, mud, extreme cold. Chopin built the BD-2 to survive Ukrainian winters, and survive it does. We're not starting from scratch. We're weaponizing agricultural engineering. Morozov leans forward, studying the fuel injection system. Koshkin has redesigned the injectors to spray diesel in a finer mist, increasing combustion efficiency. The governor system, which limits tractor engine speeds to prevent damage, has been recalibrated to allow sustained operation at 1,800 revolutions per minute, 600 revolutions per minute higher than the BD-2's maximum. The oil circulation system is enhanced with additional pumps to handle the increased heat and friction. The room remains quiet. Finally, Kuczynski speaks. If this works, if you can actually get 500 horsepower from a diesel engine this size, it changes everything. German tanks will have half our range. They'll be burning gas that ignites from bullet strikes. Our crews will have a chance. If it works, someone mutters from the back of the room. April 1938. Engine testing facility, Kharkov. The first V-2 prototype sits on a test stand, connected to a maze of measurement instruments. Koshkin and his team have worked through the winter, manufacturing components in secret workshops across Kharkov. The aluminum engine block came from the tractor plant, then underwent extensive machining. The crankshaft is forged steel, balanced to tolerances 10 times tighter than agricultural standards. The supercharger housing is still warm from the casting foundry. Chief Mechanic Vasily Krulov primes the fuel system, checking pressure gauges. Diesel fuel, refined to military specifications, flows through the new injectors. The cooling system circulates, ready to handle the heat that 400 additional horsepower will generate. Koshkin gives the signal. Krulov hits the starter. The V2 coughs, rumbles, catches. The sound is different from the BD-2, deeper, more aggressive. Krulov gradually increases throttle. The engine note rises, instruments showing RPM climbing past 1,200, past 1,400, past 1,600. At 1,800 revolutions per minute, the dynamometer reads 412 horsepower, not 500, but far beyond what any Soviet diesel has ever produced. Koshkin allows himself a brief smile. The engine runs for 30 minutes before he signals shutdown. As the V-2 winds down, the team swarms the test stand, checking for cracks, leaks, signs of stress. The aluminum block is intact. The pistons show no scoring. The bearings are within acceptable temperature ranges. The tractor engine, reborn, has survived its first test. But 412 horsepower isn't 500. Over the next 6 months, Koshkin's team pushes harder. They redesign the supercharger impeller for more boost pressure. They modify the camshaft profiles to optimize valve timing. They experiment with different fuel injection pressures, different compression ratios, different cooling configurations. The test stand runs day and night, the sound of the V-2 becoming the heartbeat of workshop number 522. December 1938. Prototype Assembly Hall. The first A-20 tank prototype receives its V-2 engine. The design is controversial. Sloped armor that deflects shells, wide tracks for mobility, a 76mm gun. But it's the engine that makes everything possible. Koshkin and Morozov watch as mechanics lower the V-2 into the engine compartment. The fit is tight but deliberate. The engine's compact dimensions, inherited from its tractor origins, allow more space for fuel tanks. The A-20 will carry 460 liters of diesel, giving it a theoretical range of 300 kilometers. German Panzer IIIs, burning gasoline, manage barely 150 kilometers before refueling. The engine mounts incorporate rubber isolators, reducing vibration transmitted to the crew compartment. The exhaust system is redesigned to minimize thermal signature. The air intake includes filters robust enough to handle the dust of steppes and deserts, another inheritance from the agricultural BD-2 design. Every component reflects a philosophy. This engine must run anywhere, under any conditions, when soldiers' lives depend on it. January 1939. Kubinka Proving Grounds, Moscow region. The A-20 faces its first official trial. Soviet military observers, skeptical of Koshkin's radical design, watch as the tank accelerates across frozen ground. The V-2 roars, pushing 30 tons of steel to 48 kilometers per hour, speeds that make the observers exchange disbelieving glances. German Panzer-3s manage 40 kilometers per hour. The lighter Soviet T-26 tanks, with gasoline engines, reach similar speeds, but lack the armor and firepower of Koshkin's design. But speed is only the beginning. The real test comes during the endurance run. The A-20 must cover 3,000 kilometers across varied terrain, simulating combat conditions. For 2 weeks, the tank runs from dawn until dark. The V-2 churns through snow, mud, sand deliberately spread on test tracks. Temperatures drop to minus 20 degrees Celsius. The diesel fuel, more viscous than gasoline, flows without issue. German tanks in similar cold often refuse to start until crews light fires under their engines. The V-2, designed to wake Ukrainian tractors on frozen mornings, starts reliably every time. At 2,847 kilometers, disaster strikes. A valve spring fails, causing catastrophic engine damage. The test is over. Observers declare the design promising but unproven. Koshkin returns to Kharkov, but he's not discouraged. The V-2 ran for 2,847 kilometers under brutal conditions, longer than any previous Soviet tank engine. The failure point is understood. Metallurgy in the valve springs, easily corrected. What matters is that the core concept, a tractor engine evolved for war, has proven viable. March 1939. Koshkin's private initiative. Koshkin receives official rejection of his tank design. The Red Army prefers a more conventional approach, a tank with both wheels and tracks, called the A-20. But Koshkin believes in his pure track design, the A-32, which will become the T-34. Against orders, he authorizes construction of 2 A-32 prototypes. Both receive improved V-2 engines, now consistently producing 500 horsepower after countless refinements. The gamble is dangerous. Stalin's purges still echo through Soviet industry. Disobedience can mean execution. But Koshkin makes a calculated decision. The best argument for his design is the design itself, running, proving its capabilities. The V-2 engine, now in its final form, represents hundreds of engineering innovations layered onto the BD-2's agricultural foundation. The aluminum block saves weight. The V configuration keeps the engine compact. The diesel fuel provides range and safety. The supercharger delivers power. Every component serves multiple purposes, elegant solutions to complex problems. May 1940. The legendary drive. Koshkin orchestrates a demonstration that becomes Soviet legend. 2 T-34 prototypes, the A-32 redesignated, will drive from Kharkov to Moscow, 750 kilometers, then to Finland where Soviet forces are fighting, then back to Kharkov. Total distance, over 3,000 kilometers. No support vehicles. No special preparations. Just 2 tanks and their V-2 engines against winter roads. The convoy departs Kharkov on a gray morning. Koshkin, already ill with pneumonia, he refuses to acknowledge, rides in the lead tank. The V-2s settle into a steady rumble, consuming diesel at rates that astonish military observers. Where German tanks would need to refuel 3 times, the T-34s refuel once. The extended range, the direct result of diesel's energy density and the V-2's efficiency, transforms tactical possibilities. Tank units can operate deeper behind enemy lines, exploit breakthroughs without waiting for fuel trucks, maintain operational tempo that gasoline engines can't match. In Moscow, the tanks parade through Red Square. Stalin watches from the reviewing stand. The sight of homegrown tanks, powered by engines born in Ukrainian tractor factories, running with obvious reliability, makes an impression. The T-34 receives production approval. The V2 engine, vindicated, will begin mass manufacture. The return journey tests everything. Spring thaws turn roads to mud. The V2s pull the T-34s through conditions that would strand conventional tanks. In Finland, near the front lines, soldiers examine the tanks with wonder. The sloped armor is revolutionary. The 76mm gun outguns German tanks. But veterans notice something else, the diesel exhaust. One soldier, a former mechanic, recognizes the smell. "That's tractor fuel," he says. "You made a tank run on tractor fuel." "We made a tank run on tractor engineering," Koshkin corrects him. Everything that makes a BD-2 reliable on a collective farm makes the V-2 reliable in combat. June 22, 1941. Operation Barbarossa. When Germany invades the Soviet Union, 1,225 T-34 tanks are in service. Not enough to stop 3 million German soldiers, but enough to shock Wehrmacht commanders who believed Soviet equipment was primitive. The first encounters are devastating for German crews, trained to expect easy victories against obsolete Soviet armor. Panzer commanders watch their 37mm and 50mm shells bounce off T-34 hulls. They watch Soviet tanks operate far from supply lines. The V2's fuel efficiency allowing independent operations. Most troubling, they watch T-34s take hits that would immolate German tanks, diesel fuel absorbing bullets without igniting. German after-action reports describe the T-34 with alarm bordering on panic. Shells simply ricochet off. One commander writes, "The engine never stops, never catches fire. Range appears unlimited." Wehrmacht intelligence scrambles to understand how the Soviets achieved such a leap in armored warfare technology. German engineers examine captured T-34s, finding the V2 engine. The discovery of a diesel engine producing 500 horsepower from 38.8 liters challenges German assumptions about what's possible with diesel technology. German tank designers begin urgent work on diesel engines, but they're years behind. The Maybach HL-230 gasoline engine that powers the Panther tank produces 700 horsepower, but consumes fuel at rates that limit German operations. The Tiger tank's Maybach HL-230 is powerful but mechanically complex, requiring extensive maintenance. The V2, in contrast, inherits the BD-2's agricultural durability. T-34s run for months with minimal maintenance, kept operational by crews with basic mechanical knowledge. 1942 to 1943, mass production. Soviet factories evacuated eastward before German advances begin producing T-34s by the thousands. The V2 engine, designed for mass manufacture in tractor plants, adapts seamlessly to wartime production. Factories in the Urals, Siberia, and Kazakhstan stamp out V2 components 24 hours a day. The aluminum block requires less strategic metals than steel. The design's relative simplicity, compared to German multi-speed transmissions and complex fuel systems, allows semi-skilled workers to assemble engines quickly. By 1943, Soviet production reaches 1,300 T-34s monthly. Each tank receives a V2 engine that represents the culmination of Koshkin's vision, agricultural reliability meeting military requirements. The engine that began as a desperate adaptation of tractor technology has become the standard by which all other tank engines are measured. German intelligence estimates that the V2's fuel efficiency alone gives Soviet tank units a 50% advantage in operational range. The Battle of Kursk in July 1943 demonstrates the V2's impact on strategic scale. Over 3,000 Soviet tanks, most powered by V2 engines, faced German Panzers in history's largest armored battle. Soviet tanks maneuver aggressively, exploiting the V2's reliability to conduct operations German commanders consider reckless. When German tanks need refueling, Soviet tanks press attacks. When German tanks break down from mechanical stress, Soviet tanks continue operating. The V2 doesn't win the battle alone, but it provides Soviet commanders with tactical flexibility German forces can't match. Mikhail Koshkin never sees his creation's full triumph. He dies September 26, 1940, from pneumonia contracted during the legendary Kharkov to Moscow drive. He's 48 years old. The illness he ignored to prove his tank's capabilities claims his life before the first T-34 sees combat. But his engine lives on. The V-2 powers not just the T-34, but also the T-34-85 upgrade, the T-44, the T-54, and variants of Soviet armor into the 1960s. Over 60,000 V-2 engines are manufactured during the war. Millions more in peacetime production. German engineers, examining captured T-34s throughout the war, write reports acknowledging Soviet technical superiority in engine design. The diesel engine provides operational advantages we cannot overcome with current gasoline technology. One assessment concludes. Post-war, Western armies adopt diesel engines for tanks, validating Koshkin's 1937 insight. Modern main battle tanks, American M1 Abrams, British Challenger, German Leopard, all use derivatives of technology Koshkin pioneered when he saw potential in a tractor engine. The tractor that inspired the V-2, the BD-2, continues production until 1949. Farmers across the Soviet Union plow fields with engines that share DNA with the motor that powered Soviet victory. In Ukrainian villages, mechanics who worked on both BD-2 tractors and T-34 tanks tell stories about the engine that served two masters, feeding the nation and defending it. In Kharkov, a monument stands to Koshkin and his design team. Visitors see a T-34 tank, preserved, its V-2 engine accessible through an open maintenance panel. The aluminum block still shows machining marks from 1940. The V configuration is compact, efficient, purposeful. Tour guides explain the engine's agricultural origins, the impossible deadline, the brilliant adaptation. Most visitors are surprised. They expect revolutionary technology to emerge from military laboratories, from purpose-built research programs, from teams with unlimited resources. Instead, the engine that changed armored warfare came from a designer willing to see past conventional thinking, to recognize that the best solutions sometimes hide in unexpected places. A tractor engine, designed for Ukrainian farms, evolved into the heart of the tank that broke the Wehrmacht. The achievement wasn't just engineering. It was vision, the ability to transform the ordinary into the extraordinary when survival demanded nothing less.